Okay, so here we're just working with a try. So they've kind of given us this partially filled up try. So first we need to figure out what words are in the try, and then we need to add new words. So let's first just list what words are here. Okay, so the way you figure this out is you kind of walk through some path in the try, and if you end in I guess this box here, then you know that whatever path you just traversed is a word in the tree. So for example, in is not a path in the tree because after the n we don't see none of the children are like a box, right? Um, so in is not in the tree, but there are other ones. So for example, let's say we want to figure out what word is associated with this box over here. We just kind of go figure out what path got us there. In this case, it was inch. So inch. Okay. Let's look at this box. This box, your path would have to be index. Index. Okay. And the last box, I don't know why I drew two. Crap. The last box is this one, and you had to do info to get there. So info. Okay, so those are the three items in the tree. Oh, it's this glitch again. I think if I do this. Okay. Info. Okay, so we have the words in the tree. Now we're just going to insert three different words, or three additional words: indent, inches, and then try. One quick clarification: even though these are lowercase and these are uppercase, that's probably just an error on our part. So I'm just gonna pretend that indent, inches, and try were all uppercase. Shouldn't really make a difference. So okay, let's first do inches because we already have inch. Adding inches isn't going to be that much harder. So we get to kind of reuse the inch from whoever added it previously, and that's one of the benefits of the try, right? Even though there's inch, we added inch and inches. We're only adding two additional characters at the end, right? So it's like we're saving a bunch of space. So right off this inch, we have this this edge where the edge is labeled E, and then the next edge is labeled S, and then to tell the try that this is an actual word, we need to add our box. Okay, so there's inches. Okay, now we can do indent now. So we're at here, we see I, we can take the I, we see an N, we can take this N, we see D, we can take the D, and then we take the, what comes next? E, yeah, E, take the E, and now we're looking for an N, right? That's the next character in indent. We don't see an N, that's okay, we'll just make one. So I'll make it down here. So remember, the node is not labeled N, but the edge is labeled N. So just like, that this edge is labeled I, this edge is labeled F, the nodes aren't labeled anything. Okay, so that's the edge labeled N. Draw a node there. And from the N, we need a T. We'll have to make that, that's fine. T. And there's no more letters, so let's tell the try this is actually a word and add a box. Okay, so that's indent. We can double check by doing the same thing we did from like part 1 to figure out the words. You just go to the box and kind of work backwards, and yep, that's indent. Okay, now try. So for the previous two ones, indent or inches and then indent, we got to use other letters in the try to save our space. For example, inches only added two things, E and S. Indent only added two things, N and T. But try, we can't use anything from the tree. So off the root node, we need to make a new, I'm going to draw a super long one down here just to make it cleaner. And this is going to be labeled T. And then R. And then I. And then E. And then to tell a try that's a word, we can add our box. Okay, and if we work backwards, yep, that's try. Okay, and that's basically it for this question. It's not too complicated. You just need to. This is a mechanical kind of question, so kind of low hanging fruit. If you if you were implementing this, one thing to note is that each node, so like I said earlier, the node itself doesn't have a like letter associated with it. It's the edge. So for example, this node, whoops, did not mean to erase that. So for example, maybe your node, if you made the node class, it would probably just have like a map, right? So map from character to another node, and maybe that's, you call it edges, but it doesn't have like a character instance variable. You don't need that. And maybe you also want to give it, instead of the box, what you can also do is have instance variable Boolean. Maybe it's called underscore exists. And maybe you only set it to true if that node is the end of a word someone added to the tree. So for example, maybe let's just say for the nodes that exist, you color them in, in terms of the visual to try. Then I'd color in this H because inch is in the tree. I'd color in S because inch is in the tree. I'd color in T, E, X, and then O. Yeah, right? So inch, inches, index, indent, info, try. Yeah, so that, like, you didn't need to do this for this question if you're just interested in, if you want to implement this, for example, then that's another way to implement it instead of having this, like, the box thing. Yeah. Okay, so the next question, we're going to do the next video, we're going to be talking about skip lists.